This is Kyle with Maximum Effort Robotics. Today we are going to look at doing some belting, making some belting for the drive on our Antweight robotics kit. My version is Synthwave. And we are going to take this guy's seen a little bit of love, already been through an event, but we're going to go ahead and go through the steps I take to make this drive belting here. So what we do is we're just going to pop this old one kind of out of the way here. I don't measure something if I can eyeball it. So I'm going to eyeball this. I take the length of this 2mm belting from McMaster-Carr, and I run it through the carbon fiber printed pulleys here, drive pulleys. I'm going to line up right about where we need to go. I like to go a little bit long because our joining process is going to cost us a little bit of length here. So we're going to go a little bit long, pull it a little bit loose, and I go ahead and put my thumbnail right where I think I'm going to need to make the cut. I pull it free. Go ahead and make that cut. And I can go ahead and set aside my extra belting. We're going to take a soldering iron. I like to just prop it up. It doesn't need to be handled for this much. In fact, if you have a pedestal or helping hands or something to prop it up with, that is the best bet. And you're going to take the belting, both hands here, and kind of touch. You want to touch it to where it's flat on both the incoming surfaces, flat in relation to the soldering iron. And just touch it on the iron there until both ends good and liquefied. I like to let it go a little bit extra because I know how much length we have. And just bring those in straight together. I've looked at doing this on a bias before, thinking I might gain some extra strength. I did some testing with it, and that did not help. In fact, the strongest orientation I've been able to find is just straight on, flat surface on flat surface. As it's cooling, I like to go ahead and kind of press in from the sides there. Get that joint to be a little bit more uniform diameter with the rest of the belt. We are going to test this because it definitely is a trial and error situation on how strong your joint is there. I'd rather it come apart right now than in the middle of a fight. I have used this same, we're going to go ahead and smooth it out, so I'm reheat it and press it down a little bit more. Use the same belting for drive for this Antweight, drive for my beetle weight. Use the same belting for one of my ferry weight weapons. And I haven't had any failure of any breakage failures. It does wear out over time, wears smooth, and then it'll wear really thin over time if there's any slippage. So you do want to get proficient at making these. This one, we're going to test it out. It may even be a little bit big because that connection doesn't normally work out so smoothly the first time. So we'll slip this on here. Slip this on here. And then see if we are too loose. I think we are a little bit loose. We're going to have to take a little bit more, out of it. As far as the joining, you guys can just cut. I'll actually go ahead and show you how to cut out the joint so you get another good solid connection there. But as far as the joining, that is the process. And you'll do that until you can put it on there and it's going to hold tension. You can even usually get it on without having to remove the wheels, but if I have to remove one, I like to remove this front one. So as you can see, it is our free rolling wheel, as opposed to our direct driven wheel, which is our back one here is direct driven. I'm going to be putting up a walkthrough on the whole kit assembly here in the near future, and then also one on making these tires. I've had some questions about the material and the process for making these tires. So we're going to cover that as well, and that will kind of lead into our kit, some of our kit assembly stuff. I'm going to try to keep on producing good kit assembly and upgrade part installation stuff, as well as some additional combat footage of the kit as we go here. So keep your eyes out in the near future. We got a little bit off-centered, so we were trying to line it up. We'll see if it takes. To be honest, it worked so well the first time. I'm okay with there being a mistake if there is now, because I want you guys to see that it is not always that smooth. Actually, that welded together pretty well there. I'm going to make a liar out of myself, and this went really easy. If it does not, guys, if you're able to pull it apart pretty easily, just reheat and weld it again. You saw I had to lose some length there, and that is it's kind of expected with this process. You can always take some away. You can't add any back. So if I always like to cut it long, and then I can nope, my iron fell asleep here. I like to cut it long, and I can always cut some length off if I need to make the belt tighter. The nice thing about these drive belts, or using these for drive, is that they're pretty forgiving. I've designed these pulleys to not be super tight. You see, I actually heated it just then too much, and it wants to separate now. I've designed these pulleys to not be super tight tolerance, so that you have some forgiveness in the size of this joint here. And then, of course, the belt itself is stretchy, so you have some forgiveness in how tight the circumference can be of the belt itself, and still get some pretty good performance out of it. We'll be shipping out with these kits some extra length of this belting, probably enough for 2 additional belts, one whole set. And you guys can reference back to this video for the assembly of the belt. That way you guys get some hands-on experience with doing this, and an extra set of belts with your kit. I like to use whatever materials are most readily available and budget friendly to do these kind of things. you can see. There we go. On that note, we will come back to these tires again soon, go over their material and then the process for making them. All right, guys, see you soon.